Still waiting. Okay, Vicky, you can start.
Yes, my name is Victoria Hatton. I'm in the politics department at the New School, and I'm here to welcome everybody to this fourth salon of PERN, which is the Platform Economies Research Network. We've been meeting for several years around questions of data and the production of various forms of value. And if you'd like to learn more about the network, of what we've done, who we are, who's in the group, you can go to platformeconomies.net and see more information there. Today, my job is really just to kick us off and to welcome the 100 or so people who have registered for the event in 3 different time zones. So we really appreciate you making time to be with us here today. I'm going to hand it off to Leila Lin, who's one of the members of the network, and she will introduce the speakers for today. Thank you very much. All over to you, Leila.
Thank you, Vicky. So our guest today, Florian Jaton, is a sociologist of science, technology, and computing. And he's currently a senior researcher and lecturer at the STS Lab at the University of Lausanne in Switzerland. His latest book is entitled The Constitution of Algorithms, which is also the main subject of our discussion today. The moderator of the salon today is Angèle Criston, a sociologist and assistant professor in the Department of Communication at Stanford University. Angèle studies how algorithms and analytics transform professional values, expertise, and work practices. Last semester, we actually held a salon discussing Angèle's latest book, Metrics at Work, Journalism and the Contested Meaning of Algorithms, along with James Spies, who's also a member of the network. So for those watching us on the live stream, you can find all the past recordings of our salons on our website, platformeconomies.net/salon. So with that, I'll now invite Florian to give a short overview of his work. Thank you.
Well, thank you very much for the introduction, and thank you also for having me here. I mean, it's a pleasure to be here tonight, or this afternoon, or whatever with you. So yeah, I just do a brief maybe overview of my work and where I come from intellectually, maybe, and also how I ended up being interested in the topic of algorithms. Hopefully, it won't be too long, so that we can move on to the discussion. So actually, I'm a political scientist and sociologist by training, and at my university at that time, there was, and there still is actually, an important Bourdieusian tradition. So I was trained actually really in Bourdieusian sociology, and we learned the different facets of this very specific sociology. But there was also a very strong emphasis on ethnography in this kind of program. And we learn how to prepare field work, how to prepare field work, how to take notes on the fly in different notebooks and so on, how to conduct interviews, and this kind of basic things that, well, are central to the practice of ethnography. And but there was a special class in this program, which was a practical workshop, and we had to find a field site, and we had to find a topic, and then we had to do a kind of small ethnographic inquiry. And I remember that I spent 1 week actually in a small bar where people made bets on horse races. And it was fascinating, by the way. But the problem was that the kind of Bourdieusian theory of field and habitus, to see it quickly. So this kind of theory tended to stifle the empirical elements I was compiling at that time. And I was asked basically, and we were asked to confirm the theory by means of empirical elements. And this was pretty sad because the things that were happening in that place were not directly related to the theory. And also gambling was quite technical, actually. It's quite a technical activity. There are screens, there are statistics, there are all kind of lay and complex computations at work. And at that time, I was looking for people who wrote about all that, about the kind of techno-mediated social practices. And this is how I discovered science and technology studies, actually. And first, through the wonderful book, by the way, The Addiction by Design. And then I discovered the STS classics like Laboratory Life, Manufacture of Knowledge, and this kind of literature. And I tried to make something out of these new inspirations. And for my master's thesis, I had the opportunity to do an internship in an architect's office. And so I stayed in this office for a couple of months, actually, and I could follow the construction, I mean, part of the construction of a hospital. And again, this was fascinating, but also sometimes frustrating because architects rely a lot of digital devices and a lot of software, actually. And so many times my ethnographic inquiry had to stop in front of these devices that were considered kind of black boxes, if you will. And it was quite frustrating because I was also discovering at that time actor network theory and so on. I mean, now I moved on, but at that time I was discovering that, and I was discovering also the amazing capacity, I mean, the amazing flexibility, if you will, of this theory. But still, in front of these digital devices, in front of this software, the whole theory appeared quite limited. And so after my master's thesis, I wanted to explore a little bit and to push the theory to that limit, if you will. And so I had the chance to meet the right people at the right time, I guess. And so I met a computer science professor who was curious about almost everything. And she basically told me that if I managed to get funding for a PhD, I could stay in her lab, in signal processing lab, to do my ethnographic stuff, basically. I mean, I had to respect a couple of rules. I mean, I had to participate into the laboratory and so on. But I mean, it was okay for her if I managed to get the funding. And it was in 2013, I think. And at that time, it was also the beginning of the whole digital humanities bubble, so to speak. And so I could kind of instrumentalize this kind of hype around digital humanities to get my ethnographic project funded. And so I did get the funding, and so I had to do the investigation into the construction of new signal processing models, which are also called algorithms. And so in parallel to that, the whole topic of algorithms became quite salient in STS. But a couple of years later, I believe, like in 2015, I think there was, for instance, the release of Frank Pasquale's book, Black Box Society. There was also the launch of the Big Data in Society journal. So there was many things going on related to that topic at that time. And the main analytical lens was quite distant at first, and it still is in a sense. And in that sense, it appeared quite problematic to me, this kind of distant analytic lens. And so kind of lens, if you will, that relied a lot on official accounts of computer science, like published papers and manuals. And what I was seeing during the inquiry was that, well, in order to publish papers and in order to publish manuals, you need to do a lot of things that are just invisibilized if you just rely upon these kind of materials to analyze what's going on in computer science. And so, well, there still is, I mean, there still is a lot of social studies of algorithms, and many people talk about it. And now there is the whole AI hype, so it's even more popular. So it's quite also difficult to propose something because the whole domain is quite competitive in a sense. And so luckily enough, I got a grant that helped me transform the PhD into a book. And so now there is this book, but it was a long process to make it happen. And as a consequence, the elements in the book are already quite old. So it's kind of a contemporary history almost now. And so this leads me to the thing I'm trying to do now, which are basically kind of follow-ups on the book. And now I try to kind of explore the mundane and like day-to-day work of people who design and apply and use machine learning algorithms, which are specific kind of algorithms that use probabilities to design function approximation. And so that's what I try to do now. It's not easy because you need funding to launch that, and it doesn't always work. But in parallel to that, also, I start to get a better idea about what is needed concretely in order to shape new algorithms. But I still struggle a little bit to kind of connect these very empirical elements and practical elements with broader issues related to political economy, to say it quickly. And one way to make this connection maybe to start with the issue of what I call ground truthing, which is basically the action of designing and handling and like maintaining ground truth databases, which are, well, referential data sets that delineate the world upon which an algorithm can be built. And so, according to this kind of standpoint, the algorithms are devices that try to retrieve things and kind of recreate the very small world from where they initially derive. So they are retrieving entities, and so they retrieve things. And I think this property of algorithms can be used to better understand broader political economy processes, to say it quickly. So, so this is kind of in parallel to my desire to continue to inquire into very practical activities. I also try to relate that to broader economical processes. And so I'm not an expert on that. This is important to just make this precision, but I'm a reader of like recent social studies of economy and finance, and also the like what is called now assetization of things and so on. So I'm a reader of that, but I'm not an expert. So yeah, so it was already pretty long. So I'll stop that, but thank you again. And so we can move on perhaps to the discussion.
Thank you so much, Florian, for this kind of background and kind of introduction of how you got to that topic and to the wonderful book that we got a chance to read, The Constitution of Algorithms. So when reading the book, I was just really struck by how necessary that kind of approach is, especially at that moment. And I say this also as an ethnographer of algorithms, but who kind of looks at the other side of it, meaning the reception, right? And so looking at how these kind of computational procedures are embedded and put to use within institutions, organizations, occupations, fields, and just like, kind of looking at the ramifications and the way in which these kind of pieces of technologies are incorporated within kind of more complex socio-technical systems. And so it was fascinating to see, so to speak, so not the production side, but the constitution side, right? And to see how so many of these computational procedures kind of come into being, especially given the fact that some things that I've been kind of writing and thinking quite a lot about, which is that most of these systems are being built in tech companies. And as many of us know, getting access as ethnographers to tech companies and to the engineers and computer scientists developing these algorithms has become increasingly complicated in recent years, right? And so given that kind of that problem of access, which is really, I think, something central in the study of algorithms right now, and especially in trying to get to this kind of like grounded empirical ethnographic approach of how people design these things, I think that it's in a way kind of surprising that we had to wait until 22 in your book to find kind of a lab study, right, of algorithmic development. And in a way, it kind of made me think like, I wonder how many classic STS lab studies could be rewritten or reinterpreted as being about kind of algorithmic development, right? And I don't know, it's just kind of, because I mean, that's what many scientific labs do, right? I mean, not all of them, and certainly not to the degree that you observed in the lab you studied, but certainly algorithmic and computational procedures, as I see with my STEM colleagues at Stanford, are kind of very present in most labs in kind of scientific and engineering disciplines. So that said, you got amazing access and just like really get us to think hard about the different steps that go into kind of developing and constituting these algorithms. And so I think that as we mentioned before, one of the key concepts and the key questions that emerges from your book is this question of ground truths and how computer scientists and developers like think about ground truths, and especially how this definition of ground truths, which basically is kind of manifested in the constitution of training data sets, and training data sets that are then kind of used to develop and to develop algorithms that are then tested on kind of similar but different data sets, kind of get defined, and how that original kind of moment of definitions then really shapes in so many different ways, like all the questions that come later, right? And I think that that's some things that you raise really well in your book. And so I think that my first question there, in many ways, is really about like, so let's think a tiny bit more about this question of ground truthing, and you know, and I think that even just as a concept, it's really useful. So I just like, it's really just to encourage you to to expand a tiny bit more on some of the questions that you introduced in the book. In particular, I was really curious. So on page 70, not to put you like, you know, in kind of directly kind of into like, you know, page 70 of your book, but you talk about like the constitution of a specific training data set based on 632 images of human faces from Flickr, right? And so you explain that this is how, and you talk about the kind of role of saliency kind of criteria in kind of using these human faces for detection. And that like really kind of struck me in part because there is a big literature in computer science right now about the role of especially kind of bias and inequality in the constitution of data sets for facial recognition, right? And so here I'm thinking in particular of the paper by Burulamwini and Jebru about gender shades, right? Showing that the kinds of data sets that are being used to develop facial recognition software programs typically overrepresent white male faces and much less female faces and darker skinned faces, which means that typically facial recognition algorithms perform especially poorly on darker female faces, right? And I was a bit surprised that like this doesn't appear at all in your analysis. And so I was wondering, like, so could you tell us a bit more about the specific processes that went into selecting faces in this ground truthing mechanism, right? And again, I think that this is not at all opposed to what you say in the book. In many ways, it goes in the same direction, as in the algorithms can only answer questions that are possible to ask given the training data that algorithms are being built on, right? So it's really this kind of social construction of reality that's happening at the kind of training data moment. So perhaps I'll just stop here to open up the discussion.
Well, thank you. So many things. I didn't reread the book. I mean, I'm terrified by the idea of reading it and finding mistakes. So I didn't do it, but I think I remember quite well, hopefully. And so, yeah, I mean, now the literature has evolved a little bit, and now there is a whole kind of like social movement around biases and training data sets, and this is extremely important, I believe. And there was this terrible anecdote about a black person who was arrested twice. I think it was in Chicago. I don't remember exactly, but first time because. The face detection algorithm of the surveillance system mistakenly took him for someone else. So he was arrested one time, and the second time because it was just a black guy in the street, and so it was a police officer who just arrested him for that. So these kind of terrible anecdotes are kind of common now. And so the whole social movement and the whole inquiry into biases is, of course, extremely important. But the book, I mean, the book, what I described happened in 2014, I think. So it was a bit prior to this whole process of critique of training data sets. So now it would have been a little bit different, I guess. But still, the question of biases is a tricky one. It's true that I don't directly deal with that in the book. There is a note on that, I think, if I remember well, like an end note. And in MIT Press book, the notes are in the end of the book, so it's difficult. It's not quite the best way to put it anyway. I think there is a note about this. And if you consider the fact that, well, algorithms derive from ground truth data sets. And I think this is something we can, I mean, this is a fact. I mean, if you inquire into that, it's the first thing you notice when you go into a computer science laboratory of applied computer science. Ground truth are everywhere, and this is the main topic of discussion, because without them you cannot do anything. So we can acknowledge that, I believe. But if you consider algorithms that way, as retrieving entity, the question of biases starts to be a little bit different for the case of machine learning, for instance, and for any algorithms, actually. Biases are central, and they are necessary, actually, for learning operations. So if you consider biases as external sources of information, you cannot do without them, because if you don't bias your model with external sources of information, you cannot design a learning function. So it must be, I mean, no, if you don't have bias, you don't have any learning processes. So the question is reframed a little bit then. So it's not about not having any biases, because if you don't have any biases, you cannot design a learning function. It's about which biases do we need, in a sense. So it's about, and I tried to put it in a paper recently. So it would be about kind of assessing the biases we want, instead of saying, okay, we try to get rid of biases. And I think this is the wrong direction, because there will be biases anyway. So and then the question starts to be a political question. So it means, okay, if you want these biases, then we don't agree then, and we want to fight for this kind of biases and this kind of discrimination, like positive discriminations, for instance, that could be a solution to that. So this is why I don't deal directly with biases, because it's a tricky topic if you think about algorithms as entities that derive from ground truth data sets. And yeah, so again, it's kind of I'm starting to getting into that topic now, but it took time for me, because it was difficult for me to understand really the notion of bias, because you can understand it different ways. And one way to understand it is to say, okay, they are necessary actually for learning operations. So that would be, and and by the way, I don't know if I continue. How does it work? I mean, because I just want to sorry.
Can I jump in? Hi, Florian. My name is Lotta. I'm in Sweden. And I just would like to follow up on Angel's comment or question there is, but did your interlocutors or the people you worked with, did they not at all discuss the problems of potential biases, even if this was not a political topic at the time? They did not talk about it when they constituted the ground truth.
Yes, well, and it's actually a very good point. Thank you. So there were discussions, and I think there might be discussions in other locations where people are designing new models. But one of the problems, there are also locations and places where people don't care at all about this, I guess. I don't know. And there are also places where, for instance, professors are kind of value these kind of discussions, and there are other locations like firms who don't care about these discussions, and they just want you to produce the most efficient model. But for my case, there were discussions actually, but the problem was that when you publish a new model, or when you I mean in an academic paper or in a report, the way you present your, I mean, you get rid of all these discussions when you publish them. So the way you present the model, you have to present it as something extremely confident and as something extremely efficient in order to make it published, and in order to make it exist in a sense, because if you don't publish it, it just stays in your computer or on your server. And And so the whole, and sometimes there were interesting discussions and kind of political discussions among computer scientists who are part of society. So there is also a diversity in that sense. I mean, not that much, but still a little bit. And so there were discussions, but the very sad thing was that the official account of these models got rid of all these discussions. And so the models appeared far less rich, if you will, than everything that happened in order to design these algorithms. And one of the ideas I have, but I mean this is very specific to me, but was kind of a way to value this discussion and to make them visible somehow, in order to kind of thicken the whole construction processes of models. But this is something well difficult to set, obviously, because it would entail modifying the whole way that models are selected for publication, for instance. And if you show that, I mean, if you try if you show all the hesitation that you had and all the discussions that you had while designing the model, there are good chances that the model won't be selected for publication, for instance. So it would require to change the whole selection process, for instance. So yeah, but it's true. I mean, there are discussions sometimes, but you don't see them basically.
Jerry,
So
did you
perhaps sorry,
Yeah.
if you don't mind, like I just follow up and then we can wrap this up, because this is just a tiny aspect, which again, like really, I think doesn't go against what you're saying. In many ways, kind of just add one layer to this question of ground truthing, right? But so when you say, that basically, and I put the segment in the chat, like, and it's interesting because you use the passive voice, right? It's like 800 images were gathered, mostly from Flickr, and then from those 632 included human faces, right? And so I'm just like really curious about what were the criteria, the detailed criteria that were used to first identify the 800 images and then the 632 faces. And so, you talk a lot about the role of saliency, and having like, one or several salient objects, etc. And so that, I think that point is well taken. But I'm also wondering, so like, for example, at some point you're like, oh, like that, how the computer scientists like said, hey, let's not use images of famous basketball players because because like, people could recognize this. And like, it's true that like, and again, not to be like, completely focused on the question of race, but, a lot of basketball players are Black as well. And so, or people of color. And so I think it's just kind of an interesting, potentially kind of trend to develop perhaps in a future paper, but as in like, so, were there any discussions of like variation and scope in terms of like types of faces, right? And what were the dimensions of variation in terms of the kind of faces that were included in the data set as part of this discussion?
Yeah, I mean, the whole project, it's true that this saliency project, I mean, I'm using it as a kind of thread throughout the book as well. But I followed also other projects, obviously. But this was especially interesting, I believe, because this was, I would say, the most awkward and strange project in a sense, because saliency, I mean, it's a very fuzzy concept, and trying to assess and design what saliency is, it's just, I mean, almost nonsense when you think about it. It has to be arbitrary. And so the whole project was very strange in that sense. So I mean, the arbitrariness was everywhere in that project. And it also, and the reason I chose this specific project as a thread throughout the book is that it also stresses elements that may go unnoticed if you consider a more straightforward topic like face detection, for instance, or object detection or car detection or whatever. And so it stresses the arbitrariness of these processes, but on a very obviously, if you will. And the whole project was quite awkward, actually, I believe. And there were not that much discussion about mixity or kind of representativity of faces. There were more discussions about the different size of faces, because if you have small faces, you have less information, and also kind of the position of the faces, because if you are like on the top, there is less information for many reasons, because you need the kind of the eyes in order to detect the faces. So there were more discussion about the plurality of size and position. But again, it was a long time ago. So these questions about race and diversity did not infuse the communities of applied computer science at that time. But it's really the reason I chose this topic was that it makes a lot of things obvious. And if you choose a more straightforward topic, you may not notice this arbitrariness, because it's about arbitrariness in a sense. And so, yeah.
Jerry, did you have a question?
It was just a suggestion, and the suggestion was, and maybe others know more about this, I only know a little bit about it, but a suggestion to look at the Linux Foundation, CNCF's joint projects on racial justice, because those folks, are trying to, from the way I understand it, are trying to tackle these problems from the level of ground truthing, not just from the level of code, but from the level of data construction. So so those projects, I think, are, for someone like you with Florian, with your kind of expertise, it would be incredibly interesting. And I would say from, I've interviewed the head of Linux, Jim Zemlin, and he was like incredibly forthcoming about like, you should talk to all these other people in the foundation. So like he was very forthcoming about providing access to scholars.
I'm just to tag on to that. I've heard similar discussions in the world of finance around so I don't know how this relates to ground truthing. I've learned about ground truthing mostly from Florian and Paul Dorish's work, but the question of zip codes in the United States, postcodes, and so how those, need to be rethought in terms of the design of algorithms and machine learning. But so on that note, Florian, I'm very personally, especially because of my work in finance, it makes so much sense to me, the idea that there isn't any unbiased, right? There isn't any unbiased data, right? But there isn't any unbiased really sort of anything. Like as soon as you create a definition, right? Some things are accounted for and others are not, right? That's like the act of framing, right? And so I'm really, that part of your work, I find very, helpful for what I do. So yeah, I sort of really appreciated that you're in the book, and I know this is old work for you, but sort of this focus on both sides of like the practical formation of algorithms. So not just our assumption that that there's like a mind, they're a mind, meaning like a cognitive mind operations, and computers work that way, and algorithms, like we said, we tend to sort of use that metaphor in our understanding, we meaning social scientists. So you're focused on on the one hand, this practical formation of algorithms, right? And then so it's the act of how we impute power to algorithms and the work that goes into making algorithms. For me in the book, that was just extremely helpful, because it really shows this fragility. Like you make the fragility of the algorithm sort of visible, which is contrary to what most of our accounts are all about, the ultimate power of the algorithm. And so I guess just tagging along on this question of bias, but moving a bit away from it, because your book's not really about that, is that that visibility, making algorithms visible, sort of has consequences for regulation, which is really what the bias, question brings us to. So, I'm very curious of we typically think that we should audit algorithms. This is what we hear now. We should audit algorithms. We should audit source code. That's the political claim right now. That's what regulation should look like. And your book seems to have other make other claims that like that's ex post, and that's not looking at like the definition of the problem that algorithms are meant to solve. Like that's different than just auditing source code. Am I getting that right, number one? And just if you wanted to comment on that, because I think your book has real implications for how we think somewhat differently about how regulation should happen.
Yeah, sure. I mean, many things related to regulation. It's true that what I kind of propose, but in subtext kind of, is that, well, if you consider algorithms, and I insist on that, I mean, every algorithms as retrieving entities, which are basically things that retrieve things that are already defined, and something that it might sound counterintuitive, because if you think about like sorting algorithms, well, you just sort numbers. But then you can think, well, actually, no, there is a ground truth to that, because there is first 1, then 2, then 3 that you can count. So, and it is related to our own like condition of biped mammals who were able to make counters. I mean, there is always a ground truth that algorithms try to retrieve. So if you think about it that way, every time you encounter or you speak about or you kind of criticize an algorithm, you may ask the question, okay, what's the ground truth for this specific algorithm? And I think for most cases, due to the differences these devices create right now, I think we may have the right sometimes to ask this question. Okay, what is the ground truth from which this model derives? When was it designed, by whom? And most of the time you will see that it was designed by a very small community of people, actually, like a couple of engineers in some firms, like small groups. And so this would be a way to kind of assess the inherent biases of these models. But it's kind of science fiction right now, because they are proprietary, so it's extremely difficult to make that happen. But I think this is something we may have the right to ask sometimes. And but also it's we inherit also from a very complicated history, I believe, around this notion of algorithms. We inherit from a history that considers them as kind of abstract, and it's still going on now, because if you ask someone, well, what's an algorithm, they will most of the time say, okay, it's code in mathematics, but it's kind of abstract definition. I mean, what code and what mathematics, and what is the relationship between code and mathematics, because mathematics is not code, and you can code without having a formal training in mathematics, for instance. So it's still kind of abstract and fuzzy. But there is a history, I think, to this fuzziness, and in the book I try. I mean, it's kind of it's a bit complicated. In a chapter, I try to retrace this history, and also the reason why maybe, I mean, this is a hypothesis I make, but the reason why maybe there are not that many ethnographic inquiries into well, the construction of algorithms might also be because well, we inherit from this lay conception of algorithms, and we tend to think that, okay, it's something abstract and it's something that you cannot document. But I think it's wrong. It's not abstract, and you can document it. And and also we tend to think it's very complicated and so on. But actually, no, it's not that complicated. If you compare to, well, people in bars who make bets on horse races, it's not that complicated if you compare to that. It's important to keep that in mind, I believe. And it's also, I mean, there is also the question of access. And I mean, I may say a couple of things about a small computer science lab in Europe, and so it might be different in big firms. But actually, I'm not that sure. I mean, it may be different, but maybe not, because there were, during my stay at the lab, there were many conferences and seminars of people who were alumni of this lab and who now work in Google or big firms like Instagram and so on. And they made talks in the laboratory, and they basically used the same references, and they were basically saying the same things as the computer scientists in the lab. And they were working and that's interesting, they were working in groups of similar size also as the lab, like 15 or 20 people. So I think most of the time it's small groups that function a little bit like computer science laboratories. So at least we can make this fair assumption. So that's why the question of access might not be the main problem, because as you say, Jerry Burke, some communities are willing to welcome ethnographers actually. So the question of access is not the main standing stone, if you will, to the description of how algorithms are constructed. But it's true that you need to detach from this lay conception of algorithm as something abstract and complex, because it's very practical and it's not that complicated when you look at it on the ground level, I believe.
Does anybody want to jump in?
I'll jump in. Hi, Florian. Thanks for the introduction to your work. It's fantastic. I guess I just wanted to follow up on that and maybe, just explore it a bit more. Like, it's really fascinating to hear that there's some applicability and transference around from the kind of computer science lab to places like Google and Instagram, for example. And it's clear that they share a kind of technical domain. I guess I'm asking you to speculate now, but I guess where do you think there's a point at which that that transferability between the site of the lab and the corporate lab, I guess, are there limits to that transferability? And I guess I'm thinking here perhaps gesturing to more d'Angel's work, but the kind of the other kind of pressures that play when those algorithms come to get constituted. You spoke about efficiency before, and I'm just wondering whether, if you could speculate on the kind of different ways beyond the kind of technical discussions that these algorithms might come to be constituted in those environments.
Yeah, thank you. I guess one of the main differences is that if you work for a big firm, you have more, you have a better infrastructure, for instance. So if you have to go through learning operations, for instance, you have much more means in order to accomplish this kind of learning operations, because you have more computational power, basically. But you may also have better data sets. And so this is, and so you may have a bigger ground truth. And this is a big difference. And when you browse through the main conferences in for instance, image recognition like CVPR and so on, you may see that the award-winning papers are most of the time, not always, but most of the time, from people who work in big firms. Why? Because they have first the infrastructure, the computational infrastructure, but also the big data sets. And they can use that to design more efficient models. So in terms of means, I think there is a difference. That's for sure. But the practical processes might not be that different, I believe, because you still need to go through this ground truthing process when you have to design the terms of the problem that you want to solve. And you need to organize your set according to a training set and an evaluation set, and then you have to kind of tweak your algorithm in order to get better evaluation on the evaluation set. So the whole process might not be that different, but the means to achieve it might be a little bit different. And but it's important. It's important to specify that. Big firms, basically, they do sponsor the big conferences in applied computer science most of the time. And they also, and the research teams of these big firms, they also contribute to these conferences. So there is not a strict distinction between corporate labs and well, academic labs, because these people meet and they exchange, well, like tricks, and so there are many exchanges between academia and industry, to say it quickly. So establishing a distinction between the two, I think it might be misleading. But it's interesting, by the way, because you can see that big firms send like research teams to show their results. So and they publish them as academic papers. So it might also tell something about, well, how you value these models and how you make something out of them. You don't necessarily have to hide everything, obviously, because you can show the functioning of your model, and it doesn't really matter for the firm. So this is interesting. But yeah, there is not a strong frontier between academia and industry. But I wish I could do something with the industry, but it's difficult because, of course, you cannot talk about what's going on in the firm most of the time.
So just like perhaps just to follow up, and then Leila will turn to you. I was wondering about like just, I mean, I think it's a similar version to James' questions, but that when you talk about, the role of algorithms in big technology firms, a lot of emphasis is put on the question of scale, right? And that it's a case for like startups, it's a case for algorithms, it's a case for platforms, that, really the main criterion of success or at least value is this ability to scale, right? That like, and that, it's going to grow exponentially and grow on network effects and that kind of stuff. And so I'm wondering, like, in the kind of academic context that you studied, like, was this idea of scale present one way or another? Like, did it enter into some of the discussions and negotiations between the scientists that you observed, or is that very much, in your opinion, an industry matter for developers and not so much for the academics you looked at?
Yeah. Yeah, I mean, it's a great question because it allows me to specify something important. Is that, well, academic labs, for instance, they mainly publish. I mean, it's mainly about prototypes actually. So so you publish a new like signal processing algorithm, and you evaluate its performances, and you show and you specify the mathematics involved in this model. But in order to insert that model and translate it and implement it into a broader system, there are many things that need to be done in order to do that. First of all, for instance, you need to optimize it. And this is a whole field in itself. And typically computer science labs, research labs don't have I mean, this is a specific skill. And big tech firms, for instance, are very good. I mean, they hire people whose work is to optimize this kind of prototypes. And also in being able to implement a model into a broader software system, it's also very complicated. If you want to scale it, as you say, you need people who are expert in the software system that the company uses in order to make it fit with the new model and the optimized version of the new model. And this is why it's not that dangerous, so to speak, to present your as a firm, to present your model at a conference, because you may present it in its mathematical formulations and with its performances, but then if you're not the firm, you cannot really do anything out of it, because I mean, you can do something out of it, but it will require a lot of effort. But by the way, it's interesting because the inverse is not true, because firms, I mean, I could see that, and it was surprising, but like Instagram and so on, they have people, I mean, people who work in the research labs and private research labs, they keep on being informed about what's going on during the conference. And sometimes they may also implement things that are published in these conferences within their own system, actually. And so if you manage to I mean, as a researcher, if you manage to make your model published in a big conference, for instance, and if this model is awarded a prize, for instance, there are many prizes that are awarded during these conferences, then it may be like seen by one of these people who keep informed and keeping informed about what's going on in the research, and your model might be implemented in the end in a broader software system. And so this adds a layer of responsibility also, I think, for the researchers in a sense, because whatever you may propose, it may end up in a broader system that may create differences actually in society at large, which is kind of different from other sectors of activity. For instance, what we do, I mean, what I do as a sociologist, I write papers and very few people read them. And so the impact of this paper is very, very small, actually. So my responsibility is very small in that sense. But if you design new like machine learning algorithms for applied computer science, I think the responsibility is a little bit different. So that I think it has to be included in the reflection also, and in the training actually of computer scientists.
Leila.
Florian basically answered my question, but maybe I think there's a part 2 that I could still ask. So in this 3rd chapter, you talk about like the episode of the rejection, where their first version of the paper was rejected for having not having tested their algorithm on any ground truth other than the one they created. So they're like, so it was like, so because the first version argued the main point was that their algorithm was the most effective or something, but because they didn't test it on other more larger or more established ground truth sets, it was rejected. And then you said that then they pivoted and kind of basically using the same data, same results, but just kind of turned the main argument into that actually their main contribution is the creation of the new ground truth set. Like and then that paper was not only accepted but also like won a prize, according to what you wrote. So that makes it. I'm wondering, according to this, so it's ground, like how valuable is like kind of the creation of a new ground truth set? In this case, it almost sounds like for this case, the ground truth set is more important than whatever algorithm they came up with. That just having that is already enough of a contribution. And like, yeah, I'm just generally curious. And if that's the case, then like, but however, like you also mentioned how specific the ground truths are to like the people, you know, they're kind of specifically constrained by what the purpose of the algorithm designers were going after. So ground truths are always kind of like designed for a specific purpose. And yet, like, I don't know, I'm sorry, my question has lost its track, but I'm just wondering, first of all, is it just kind of a, are they just like making that argument in order to get that paper published, or is having kind of these like new uniquely designed ground truths actually an incredibly important asset to the computer programming field?
Yeah, thank you. It is extremely valuable, actually. Ground truths are extremely valuable, and I mean, academically, you can think about it as a kind of asset, I guess, because you can generate many citations with the ground truth, actually, because every time someone uses the ground truth to design a new model, it has to quote the original paper that presented the ground truth. And so it's extremely valuable in that sense, and it is also extremely positively connoted. Even, I mean, in the applied domain of computer science, but even though it is extremely boring, actually, I mean, it is negatively connoted in order to do it because it's quite boring. It is conceived as boring because you need to do very repetitive tasks, and you need also to check the validity of the responses from the crowdsourcing companies and so on. So you need to do things that are not really related with applied computer science in a sense. But it is extremely valuable, and for different reasons actually. And this is also interesting because, first of all, most of the time, if you design a ground truth, you know the data that you kind of put into it, and you know how you frame the ground truth. So in the end, you are more able to design models that work better on this ground truth. So it might be valuable for your own work. But what I try to do now is try to understand the kind of the broader picture of the value of ground truth from different perspectives and from different domains, and this is for instance, if I can give you an example, so now I work on a project on the development of personalized medicine in Switzerland, and in that project I came across international consortium-based project that is called the Tesla Challenge project. It has nothing to do with cars, by the way, but it's a consortium-based project that aimed at designing a new ground truth data set. I mean, in computational biology, they talk about a benchmark data set, but it's technically a ground truth data set for the detection of specific molecules that are called neoantigens. And well, this is part of the whole field of like cancer immunotherapy, and neoantigens are kind of molecules for many reasons that are very important for cancer immunotherapies, but it's extremely difficult to predict what kind of neoantigens will be around cancer cells. And to do that, you need very advanced computational techniques in order to kind of predict the presence of this specific peptide that can then trigger immunogenic reaction against the cancer, if you will. So the whole project of the whole goal of this consortium-based project was to create a ground truth for neoantigen prediction. And so this project included many different institutions, like academic institutions, but also private companies. And it is extremely difficult to know which private companies were involved in that project. And it was led by an institute that is very specific, which is the Parker Institute of Cancer Immunotherapy. And Sheen Parker is, I mean, I don't know if you know Sheen Parker, but it's kind of a Silicon Valley rock star. And he became rich by investing in Facebook, and he was the founder of Napster, for instance. And so, but the whole process was to, again, to design a whole ground truth for neoantigen prediction. And so it took 4 years for many reasons to create this ground truth. And in the end, I mean, because you need a whole infrastructure, you need NGS and a whole infrastructure in order to do that. And in the end, I realized that thanks to this ground truth that was published in the journal Cell, which is like the major journal of molecular biology, thanks to that, the FDA accredited the use and the use of several computational techniques in order to predict neoantigens. And now, for instance, like companies like Personalis use computational models in order to detect neoantigens, and they refer to that ground truth in order to attest to their efficiency. And actually, for instance, this company, they had already designed these models before the ground truth, but they needed this ground truth in order to get the accreditation from the FDA, and therefore they could they could sell this service. And now, if you are a hospital, for instance, you can subscribe to this service in order to kind of predict neoantigens. So if you think about it, it's extremely valuable also for that reason, because if you And I'm not sure, but I guess also this company was involved in the whole design of the ground truth dataset because they needed it in order to enable this kind of subscription. So it's extremely valuable, but in different ways. And I think I am at least only at the very beginning of understanding how valuable these specific databases are actually. So yeah, sorry about this parenthesis, but this is an interesting example, I believe.
Victoria.
I mean, I think there might have been a queue, but I have a quick question. I really enjoyed reading the chapters, and I found the specificity about the construction of the ground truthing and the data sets really fantastic. But as we're talking now, I am reminded of being a political scientist. I want to know really what the difference is between behavioral science data sets a la sort of Michigan University style, which also are extremely tedious to construct, and cleaning up the data sets, and then were extremely valuable, and also a source of great authority professionally. What's the difference between the construction of a behavioral data set and one that's used for algorithmic processing? Is it really about the second order processes that are laid on top of the data set? So one goes to an academic set of interpretations of data with authority gained also from the data set itself and how it's interrogated. Is it then the sort of the technical aspect of the inquiry that you talked about, the retrieval process that's done then algorithmically as opposed to academically? I'm just curious, they keep collapsing back into each other for me.
Yeah, I think one difference is that, like for behavioral data sets, for instance, made by political scientists, these data sets are made by people who were also trained to that specific prospect. And what was, I mean, most of the time, I guess, but
I don't think so at all.
All right,
No.
so then it's not that different because I was I mean it may depend on the locations, of course, but I was surprised to see that many ground truth that I could see also in terms of design and construction, they relied upon very intuitive ideas actually, and the kind of lay intuitions actually. And they were supported also many times by papers in cognitive psychology for some mysterious reasons. And basically, people just browse through Google Scholars about, for instance, the notion of saliency, and so they were directed into what's very specific and very quoted paper in cognitive psychology about saliency, for instance, and they used these sources in order to frame the overall topic and the overall way to design the ground truth. And so this was quite surprising, I believe, and this may be related to something that Angèle mentioned at the very beginning, because when you read the book, if I remember well, I mean, when you read it, you may feel that I tried to establish a distinction between, well, the study of the effects of algorithms and the study of the way people shape algorithms. And the more I think about it, the more I think it's counterproductive actually to make this distinction, because you don't really escape from the question of users. And people who design algorithms, they're also actors of society, basically. So they are also using other algorithms, and there is no such thing as an algorithm in complete isolation. So there is always many algorithms that are nested. So you cannot escape from the question of users, and this is something I don't really do in the book. but it's something to keep in mind. So in order to design, for instance, in order to design a new ground truth, you will go through algorithms, and that themselves are based on other ground truths. And so yes, I'm not sure I answered the question, sorry, but this is important to keep in mind. And yes, related to the difference between, well, behavioral data set and ground truth. I mean, an important element of ground truth is that you need to have a kind of, you need to suppose an operation. That is, you have a kind of input data and output target, and you need to suppose that there is a function that transform the first data into the output target. And you need to consider this function as real within the world that is delineated by this data set. And the whole purpose of algorithms or model, if you will be to approximate this function that you have to consider real in this small world of the ground truth, for instance. So you need to assume an operation. So this is an important characteristic, because it's always the approximation of a function, actually. Even though sometimes, I mean, if you talk about people who are specialized in deep learning, for instance, they tell you, no, it's not an approximation of function, it's a real function, but actually no. They say it's a function because there is no, I mean, for mathematical reasons, they say no. But actually, no, it's logically, if you will, it's always the approximation of a function that you consider real inside the very small world of the ground truth data set. I don't know if it answers the question.
It's interesting. Go ahead. Go on to the next.
Fabio, do you want to jump in?
Sure. I think I'm like many others. I appreciated your book, and we were circling around with some of our questions around the political economy of it. And as I was listening you talk, I really realized how important and how many elements there are embedded in what you're saying. And it seems to me that almost between the fragility of algorithms and the sort of small world that you have to pretend is actually real, there seems to be an important element or value for the fiction of algorithms as truth to the political economy function of it. And I'm thinking here at different levels, right? There is the one level of, the political economy of publishing in academia, where you have to publish in the spaces in order to get the funding, in order to move forward with your career, etc. Then there is the level of, getting adopted by big tech firms or maybe moving there, and their interest in maybe having a proprietary set of data, or maybe an algorithm, or maybe and that's Keen's question later. I won't go there, but have a property ownership of that. But then there is other stuff around it, right? And I'm reminded of your Nutella example at the beginning, which in which you say, oh, it's the Nutella. Nutella was a boring old chocolate spread that became cool because of an algorithm. And in many ways, I'm thinking, well, isn't there something else that sort of props up algorithm to have that sort of, or aren't we actually making algorithm more effective, and we describe it? And there's a political economy of that, right? Of making it more effective than they are. And that's not just because Nutella is not a chocolate. It's an hazelnut spread. But beside that point, the example of Nutella is interesting because it's an economic institution in many countries, especially in places like Italy. And to give you an example, their president was a former UN ambassador, Italian ambassador to the UN, who helped dismantle Gladio in the Italian secret services. So somebody who had a real economic power, right? And so you're sort of, I think there is an interesting point here in how we sometimes, or making the algorithm more substantial than maybe they are, has its own political economy. And that is maybe very important to the story that you're describing. And I'm really fascinated in how you could trace that, and whether you have given any thought about that process itself.
Yeah, there is surely a political economy of algorithms. I mean, of algorithm as a notion. And I am always struck by that. And it's a tricky question because when there are very important papers that and books that criticize the power of algorithms, and this is extremely important, of course. But to a certain extent, it also inflate the notion, and this has also consequences, I believe. And I really like the notion of it was proposed by Maltesiewicz. It's called algorithmic drama, and it's kind of a criticism of a mild criticism of the critical studies of algorithms and on the effects of algorithms. And he says that basically, well, according to this drama, algorithms are very powerful. So this is the given. And they're also inscrutable, and this inscrutability makes them even more powerful, which in return make them even more inscrutable because something that powerful has to be inscrutable. So there is a whole kind of inflating process around the notion, which is important in itself, I believe. For instance, if to say it quickly, if there was not if Frank Pasquale didn't write his book, maybe I wouldn't have engaged myself in this inquiry, for instance. So it's very important to do that to make algorithms matters of public concern. So this political economy, if you will, is useful in that sense. But at some point, it's also important maybe to go into the other direction, which is to kind of try to deflate also this notion. And one way to do it could be to try to describe the mundane activities that, well, contribute to the design of these devices. And this is also the power of ethnography, if you think about it, because if you describe mundane activities, well, mundane activities are always very, very simple, actually. So day-to-day activities are very simple. And so you deflate the notion, and you deflate also all these problematic ideas about algorithms being very complex, and people who make algorithms being incredibly clever and so on. And if you follow day-to-day activities, you have to consider the possibility that actually intelligence, everybody is intelligent, equally intelligent. And if you consider day-to-day actions and mundane activities, you end up describing something very, very simple. And so this would be a way to counterbalance this kind of political economy around the notion of algorithm, which is still important. So I think we should do both. And so there is a possibility of coexistence, I believe, between critical studies of general critical studies of the effects of algorithms and descriptive attempts at describing very concretely the process underneath. So this is my take on it right now. But I balance. Sometimes I'm very angry against algorithms. Sometimes I say, okay, actually it's not that easy. It's a bit more complicated. We should describe more and so on. So I keep on balancing between these two positions.
I guess just to continue on that point, the reason why I was bringing it up is because it seems to me that in different contexts that maybe the same algorithm would have slightly different valuations, for instance, or impact. And so you talked about before about the translatability or not between corporations and academic settings. And obviously there's the question of, yes, they have more data, they have more computing power, but there's also the question of maybe they're going for different logics in the very design of the algorithm itself, because they need to fulfill, asset, or the need to translate them into assets in a much more substantial way, right? And so in that sense, I'm thinking the encounter of this sort of structural framing, which that algorithm is developed, as well as then the mundane practices, that's where it becomes particularly productive to think about that political economy component. And I was wondering whether you have seen that shift as you were tracing some of these algorithms maybe being then developed or brought forward or moved around in different settings.
Yeah, it's very difficult to make that connection for me, at least now. And this is one of the downside, I guess, of ethnographic work, at least for me, how to connect these very mundane and practical elements to more general like processes, because I really try to stay specific. So for me, I'm still struggling with that, to be honest. But my hope is that with more descriptions, I may be able to propose something. But for now, I agree. It's a little bit difficult. But it's true that I mean, computer scientists. I mean, those that I followed. I mean, they move around, as you said, and at the end, after a PhD in computer science, you end up working for most of the time for a big company, actually. So this is true for most of them. And so it can also be in a other field. So for instance, many people in signal processing end up working in financial institutions, for instance, because it's still about processing signals. So yeah, I mean, I should definitely do something out of these kind of reflections. But for me now, it's a little bit early, I guess. But yeah, I should think about it a little bit more.
Keen.
Okay, thanks a lot. So I had a question going around the ground truths and thinking about them again. This political economy kind of aspect of them is, can they be property? And I guess that's can they be made into property, or are they made into property? I guess maybe is another way of saying it. And if so, how? Yeah, I guess as part of that kind of thinking about them as valuable and these kinds of assets and things. Yeah.
Yeah. So I guess they can in specific situations. I guess like firms have property rights on ground truths, I guess. I cannot affirm it, but I'm pretty sure it is the case sometimes. But if you think about, for instance, the ground truth database I mentioned around the case of neoantigens, for instance. So there is no property rights on this ground truth, for instance. So because it's a consortium-based project, so it is hosted on the servers of the Parker Institute for Cancer Immunotherapy, but they have no property rights on the data set. But still, you need to ask them to get access to it. So they kind of they can decide if you can access to it or not, which is kind of strange, by the way. And for the case of this specific ground truth, again, it has, I mean, cancer immunotherapy is a very valuable activity. There is a lot of money behind this research sector. And this specific ground truth was extremely central to the whole field. And the more I dig into that, and the more the story is intricate, actually. And I was, for instance, very surprised to see that actually the Food and Drug Administration, I mean, required that one ground truth was published in Cell in order to accreditate a couple of CAR T-cell therapies that rely on the prediction of the antigens. So this specific ground truth helped the FDA accreditate a couple of treatments, actually. And so I don't know how to translate it into political economical terms, I would say. But in that specific case, I believe, I mean, technically, I believe you can consider it as a, I mean, to the letter, it has been a kind of assetization device, if you will, for companies who had already models who had designed models in order to do this kind of prediction, but who required something else in order to get like subscription possibilities and to offer subscription possibilities. So this could be a reading of ground truthing sometimes, but in some other contexts it might be a little bit different. So yeah, I'm still exploring the whole topic. But to answer quickly to the question, yes, I can. They could be a proper like a property around ground truth, but I'm not certain. But I'm pretty sure that it can.
Because just to follow up on that, there's some interesting, like some interesting, I guess, not quite contradictions, maybe, but legal. Maybe contradictions is a good term. Legal contradictions when you get to the whole notion of it being a ground truth and therefore, you know, a fact, while not being able to sort of own the facts, and therefore you got this kind of you know, interesting kind of dimension where you have to be it has to be a ground truth, but at the same time it's like it's not, you know, not being constructed as a fact. I don't know. You know, whether that goes on or not. And then, as you said, denial of access would be the only way of making it valuable if it was considered a fact. But if it's not considered a fact, then it becomes an interesting, you know, it's a construction of something. I don't know. Yeah, it's interesting.
But the other way I mean, ground truth is a vernacular term quite specific to signal processing, which is a very specific, like, applied subdomain of computer science. For instance, in computational biology, they talk about benchmarks. So it's all about benchmark data sets. But when you look at them, it's exactly the same as the ground truth, but the terminology is a little bit different, which might imply, it may imply, I mean, in terms of jurisdiction, different also processes. I'm not sure. I mean, I should dig into that, definitely.
Thanks.
Please.
So perhaps we'll do Jerry first and then Janet. Is that okay?
Go ahead, Jerry. Yeah.
Yeah, thank you. Thanks, Florian, and thanks for all the questions, and thanks, Angela. I look forward to spending more time with this book. Chapter 2 is incredibly rich from what I've read so far. You describe here and in that chapter this wonderful recursive relationship between the constitution of data sets and the constitution of algorithms, in which there's, and you, as you say, you unpack that hidden process of, you know, of creating data through constant testing, evaluation, creation of provisional algorithms that then return back into testing new data with those new algorithms, as I understand it. As I understand the sort of next wave of computing, as more and more operations move into the cloud, and more business operations move into the cloud, the next big problematic is the problematic of creating what some computer scientists call the data pipeline, right? Creating, you know, databases that are, in some people's hope, open, databases that are often unstructured, portable, workable across diverse cloud platforms. But at any rate, you know, there's an enormous movement at this point in the creation and dissemination of databases. Much of that work is being done, as I understand it, through open source. There's an explosion of small companies, as well as the involvement of all the big companies involved. So I'm trying to just get a picture when I look at this process you describe of this relationship between the constitution of algorithms at one level in a recursive process and the constitution of databases through the kind of processes you describe. I'm sorry, yeah, through the processes you described. And I'm trying to understand where this movement to create, to organize accessible and analyzable and scalable databases in the cloud, like do you have a sense of how that fits into the processes that you're describing?
So perhaps in the interest of time, Jerry, before Florian answers, I'm going to ask Janet to ask the last question, and that way Florian can answer both questions at the same time, because I don't want us to run too much after the indicated time. Janet, all yours.
Yeah, thank you, Florian. First of all, thank you so much. Really interesting to follow on Keen. This isn't really a question. I'm just wondering about intellectual property rights with respect to the ground truths. And I think this maybe relates to Jerry's question about the move to computation in the cloud, you know, open source. I don't know, I'm thinking out loud here, maybe the pharmaceutical industry keeps coming to my mind, but I actually have just a comment. I hate it when people say to me, in that article you wrote in 2005, you define X, you know, you define this thing as, because I can never remember. So I apologize for doing this, but somewhere in your book, you define machine learning as automating formulating practices. And I really, really loved that. I thought was extremely helpful to me, automating formulating practices. Unfortunately, Paul Dorish is away on a holiday, so he's not with us today. But we had a conversation where he was talking in relation to your book, right? About the point that there's no identity, right, between the algorithm or algorithms, sets of algorithms, and automation. And it seems to me like so much of what I read in the social sciences, again, media studies sort of stuff, there's that assumption, there's like an algorithm automates, and it's like this direct relationship, you know, direct causality. So I am assuming that you and Paul agree. And he refers to this kind of pernicious identity because algorithms are distributed processes, right? Like they can extend across like multiple places in code. This is beyond my expertise. And that distribution depends on the memory architecture of the computer. I'm just wondering if you have any closing thoughts on that distributed, because it really does that. If we accept that, and that's just the way the processes and operations are taking place, then, you know, it has such big implications for research. So any thoughts on just sort of the distributed nature of algorithms and algorithmic operations? Yeah, thank you. And thank you again.
Yeah, perhaps if I come back to Jerry Berg's question, I mean, ground truthing now is also an industry. So it's important to keep that in mind. And if you think about crowdsourcing platforms, I mean, it's all about ground truthing activities. And so, and funnily enough, when I started the inquiry in 2013, there were like 1 or 2 crowdsourcing companies. I mean, not that much, but now there are plenty of them. And they all put the emphasis on, well, the AI revolution and so on, which is a way to put it, I guess. But it's so now it's a whole industry, and it would be interesting to inquire a little bit more into that industry. And people did that, by the way. If you think about Gray and Surrey's book about ghost work and so on, it's about also the ground truthing industry, I presume. At least most of the time cloud-based. So so it's also important to think about it as really an industry now, and industry that is related to because I saw in the chat, I mean, someone mentioned the notion of unsupervised learning, and so I think it's an industry that is also related to all kinds of machine learning algorithms, be there supervised or unsupervised. And I think it's an important precision to make, because there is a lot of discourses right now around unsupervised learning algorithms or self-supervised learning algorithms, which is the latest instantations of like convolutional neural networks and so on. And so it is sometimes said that, well, these algorithms don't need labels to design their learning function, which is true, by the way. So they don't need labels, so they don't need ground truth. But if you want to attest to the performance of your model, you need to rely upon a ground truth data set in order to get like performance measures. And if you don't manage to get performance measures by means of a ground truth, you won't be able to make your model circulate, because you won't be able to evaluate in a sense. So I think it's an important precision to make, because unsupervised learning is still subordinated by a ground truth data set. And so it is still linked. I mean, this new area, if you will, of this new instantation of machine learning is still linked to the whole industry of ground truthing. And maybe, so the question of the distributivity and of algorithms, it's very important. I completely agree. And so I think, but it's obvious. There is no, again, there is no such thing as, well, an algorithm in complete isolation. It's always many algorithms that work upon each other's. And so in order to design a model, for instance, like a theoretical, I mean, in order to publish a new model, you need to go through many algorithms. And so that's why I try to propose, I mean, automation, it might not have been the right word, but I think something that is related to the machine learning wave, if you will, is also the experience of delegation. So it might not be a way to automate formulating practices, but it might be a way to delegate this specific work to someone else, actually, to someone else who designed a model that was specifically whose purpose is precisely to find a learning function. So the experience of delegation is very important right now, I think, because now you can use deep learning with 2 lines of codes, actually. And so you delegate a lot, and people delegate a lot, and people who delegate, they also themselves delegate a lot to other people. So I don't really know what to do with that, but I think it's a good entry point into the topic of machine learning, because it's a real experience of delegation. And so yeah, that might be my take on that for now, at least. Yeah.
Fascinating.
Thank you so much, Florian. And so we are running out of time, so we're gonna end here. I'm gonna give the floor to Vicky to kind of say goodbye and conclude the session. But thank you so much, Florian, and everybody, for the great questions and the great discussion. And everybody should read The Constitution of Algorithms, which is a really important work on these questions.
I said hello, now I say goodbye. Sorry we ran over, but thanks for keeping us all so engaged. And the next salon is on, depending on where you live around the globe, either April 7th evening or April 8th morning. But notice will be sent out and available. Thank you very much.